In this video, we're going to discuss what do forces do and how force is related to acceleration and mass. The fundamental question is, how does an object move when a force is exerted on it? The only way to answer this question is to do experiments. To do experiments, however, we need a way to reproduce the same force again and again, and we need a standard object so that our experiments are repeatable. Let's say a man is pushing a crate with the mass m, and non-zero net force accelerates the crate with an acceleration a. So let's say the crate accelerates this direction. Now, if another man joins and two people are forcing the same crate with mass m, what I'm trying to say, the second man, you're doubling the force. Then you will see that acceleration doubles. So in this situation, you have to double the force. If I have to draw, substitute these two forces with one, that would be double the length of the force. So 2 times F. Just a simple addition of two forces, like one head to tail, okay? Force 1, and then the second force. Now, when you double the force, then acceleration, in fact, will double as well. You will observe a double the acceleration 2 times. Now, another thing, if you triple the force, the acceleration triples. What you will end up noticing that the force is actually directly proportional to the acceleration. So you double the force, acceleration doubles. You triple the force, acceleration triples. Now let's repeat this experiment by keeping the force the same, but adding the mass, and see how the force and the mass are related. In this case, I'm gonna have one person only pushing the crate, and but having double the mass of the crate. So let's have 2 of this crate together. So we have double the mass. Well, you would see if we keep the force the same, only 1, okay? If you double the mass, from your experience, you would know it would be more difficult to move. So what you will end up observing, that acceleration actually becomes half. So when you double the mass, acceleration is halved. In other words, we could say that acceleration is inversely proportional to the mass, meaning you double the mass, acceleration goes down twice. While we had in an earlier case, maybe it's easier to write if I say acceleration doubles when you double the force. Let's not forget our vectors here, and the numerical value of the acceleration and a mass are mass is a scalar. So if we combine these first and a second relations, we can summarize it in a form that acceleration is proportional to the force directly proportional to the force and inversely proportional to the mass. Well, this relationship is summarized in Newton's second law, and we have already seen that the force causes an object to accelerate, and the acceleration A is directly proportional to the force F and inversely proportional to the mass. Now we can express both these results in an equation form, and we could say acceleration equals force over mass. Now, let's note that if we double the size of the factor of force, the acceleration will double, as we found experimentally, and if we triple the mass, the acceleration will be only 1/3 as great. This equation tells us the magnitude of an object's acceleration in terms of its mass and the force applied. But our experiments also had another important finding. The direction of the acceleration was the same as the direction of the force. So therefore, I can write this in a form of, in a vector form, okay? Newton was the first to recognize these connections between force and motion, and this relationship is known today as Newton's second law, that states an object of mass m subjected to forces, let's say F1, F2, F3, and so on, will undergo an acceleration A given by acceleration equals F net force over the mass, where the net force is the sum of all the forces and mathematically we have a notation for the summation, that is this sign. It's a capital letter Greek sigma. We put like this format F, we put a subscript I, and we say I, the summation goes by I and a vector, and that equals F net. Sometimes Newton's second law is known as, in a different form, it's written as F net equals mass times acceleration. And let's remember that acceleration vector points in the same direction as the net force vector does. Thanks for watching. Stay tuned for more to come. Next, I will discuss Newton's third law and free body diagrams.